In this video, we're going to do a couple linear programming examples. I'll do this first one where I've given you the system and we will maximize some functions. And we'll also do one where we look at a story problem, where we have to write the system in the first place. So, as we look at these problems to do, first thing we need to do is look at our constraints. Those are our limitations, so we will graph those limitations, and I've graphed that for you over here already. Make things nice and easy. Find the feasible region. This is the possible values based on our limitations or our constraints. We're going to use this to maximize our objective function, and I've given you 3 objective functions or expressions here to maximize. So let's look at this graph. In order to maximize these expressions or these functions on this system of constraints, I need to find the vertices of my feasible region. So that would be a 4, 3 here. This would be 0, 2. And this one would be 2, negative 1. Basically, we plug each one into our function and see which one makes it the greatest. So if I look at this first one for A, I'm going to look at 0 plus 2 times 3, or 2 times 2 is 4. I'm going to go 4 plus 2 times 3. 4 plus 6 is 10. I'm going to go 2 plus 2 times negative 1 is going to be 0. So my maximum value is 10, and this occurs at the point 4, 3. So to maximize this expression, this would be 10 at the point 4, 3. Let's look at the next one. To look at my letter B, I do the same thing. I take x minus y. I look at that at all 3 of my vertices. So we're going to do 0 minus 2 is a negative 2. 4 minus 3 is 1. And 2 minus a negative 1 is 3. So this is my maximum value is 3 at the point 2, negative 1. So we'll see my maximum value is 3, and that's at the point 2, negative 1. Now we'll do our third one. (2x minus 3y). And we'll look at that at each point. So 2 times 0 minus 3 times 2 is a negative 6. 2 times 4 minus 3 times 3 is a negative 1. And 2 times 2 minus 3 times negative 1 is 7. So my maximum value is 7 at the point 2, negative 1. You can't always tell just by looking at the graph which is going to be the maximum value or minimum if we want to minimize. But again, the idea with linear programming is the maximum or the minimum is always going to occur at one of the vertices. So all we're going to do is check the vertices and find which one's the best. So now let's look at a linear or a story problem. Here we have a Souls Associate, plans to mix as much paint as possible, have colors A and B. You got 32 units of blue dye and 54 of red. To make A, you need 4 units of blue and 1 of red. To make B, you need 1 of blue and 6 of red. We want to find out how many should I make of each color. So I'm going to start by organizing the information I have into a table. So I have 2 colors, A and B. So I'm going to start by saying I got A and I got B. So we're going to be using blue dye, and we're going to be using red dye. We use blue for both A and B. We use red for both A and B. So that's why I put one on the columns, or one on the rows, one on the columns. They have to cross-reference. As we look, we have 32 units of blue. So blue has to come down to, we have 32. So I'm going to make down here a total column. And red, I have 54 units. So now again, we're looking at color A. We're going to go 4 units of blue. So for A, I need 4 blue and 1 unit of red. For B, I need 1 blue and 6 red. That's all the numbers that are in there. So, but I have these cross-referenced, so I know for A, I know what's going on. For blue, I have all the numbers I have going on. Now I'm going to figure out what should my variables be. And I'm going to go to the end of the problem. It says, how many gallons of each color should she mix? So the colors are A and B, so those are going to be my variables. So I'll make this X and this Y. If I go use X and Y, I'm going to say here on the side, X equals gallons of of A. And Y is going to equal gallons of B. If I use my variables A and B, that might be a little easier, and then I probably wouldn't have to write that on the side. But since I have A is, here's my variable for this, it's going to apply to my whole row. So I'll make this an X and this an X. Y applies to all the B, so this is a Y, this is a Y. This is my total here. So here's one inequality. 4X plus Y. We're comparing that to 32. Since this is all that I have, that has to be bigger. What I have has to be bigger than what I use. So I'm going to come the same thing for the red, and I'm going to go X plus Y is less than or equal to 54. Now, I got to remember these two. X has to be bigger than 0, and Y has to be bigger than 0. These are the common sense constraints. You can't make a negative amount of paint, so we do have to include that as we're doing some of these problems. What's impossible? We're looking at all of the limitations. These are my constraints. This is what's going to limit what I can do. Now I also need my objective function. What's my object? My object is to make the most paint possible. So how do I figure out how much paint I'm going to make? Well, that depends on X and Y. It's just going to be X plus Y. I add how many gallons of X, how many gallons of Y, or how many gallons of A, how many gallons of B. I add those together, and that will give me how much paint have I made. So let's put this all together and graph our constraints. To save time, I've already done it. So here is my feasible region. Here's my X is greater than 0 and Y is greater than 0. This is my 4X plus Y is less than 32. This is my X plus 6Y is less than 54. And here is my feasible region. So let's go ahead and find our vertices. So this looks like 0, 9. This one looks like it would be 6, 8. This one looks like it's going to be 8, 0. And this one, of course, is 0, 0. So to figure out what's my best bet, I'm going to go to my objective. So I'm going to just list out my 4 points. 0, 9. 6, 8. 8, 0. And of course our old favorite 0, 0. And I'm going to plug each one of these into my paint function. See how much I make. So this is going to be 0 plus 9 would give me 9 gallons. 6 plus 8 gives me 14 gallons. 8 plus 0 gives me 8 gallons. And 0 plus 0 gives me 0 gallons. Of course, if I make nothing, I get nothing. So my maximum is going to be right here. So again, if I think back to what was my question is how many of each color should I make? So my answer to this problem should be make 6 gallons of X, which we said was color A. So then and make 8 gallons of B. Again, when you give this, you get a problem get written to you in words, give the answer in words. Explain what your answer means. Don't just give the coordinate or give me the maximum. I want to know what do I make of each, so that tells you what do you make of each.